Alright, so in our last video we figured out how to get a ball to draw on the screen and kind of bounce around. The problem is with this scheme, the way we've written it, is it's not easy to add new balls. So, like, for example, in micro worlds, anytime we want to add a new turtle to the screen, we can do it, you know, from the toolbar, or we can do it directly from code. If we say new turtle T1, let me make this a little bigger. Like that, yeah. So if we say new turtle T1, puts a new turtle on the screen. It's initially not visible, so we can ask T1 to show himself, show turtle, and there he is. Or and then if we want, we can ask T1 to, I don't know, go forward 50 for us, and we can put another new turtle on the screen. New turtle T2, and we can ask T2 to show turtle. So now we have two turtles on the screen, and all the stuff that this turtle knows how to do, this turtle also knows how to do. Both these turtles know how to move forward, they know how to turn right, and all this, that kind of jazz. But in our example, we really only have the means right here of putting one ball on the screen that knows how to do this stuff. So let me show you how to rewrite this so that we can add more balls to the screen. So what I'm doing is, in this example, and let me just run it to show you it does exactly the same thing. There's nothing new. But after I explain this, I'm going to show you how easy it is to add more balls to the screen. So what I'm doing here is building a ball class. So the basic idea is I'm building a thing. Like here we have a turtle, here we have a text box. We can add new text boxes to the screen too, right? We can say new text. How do I want to do this? Let's call it, let's say score. Stick it over to the side a little bit. So 200 and 100 is the XY coordinates, the position that the text box is going to be in, and we'll make the size of it, say 50 by 50. I think I got to scooch this a little bit. 50 by 50. And then boom, we have a new score box, and then we can ask the, you know, we can stick a score in here. We can ask the we can ask score to do stuff, like we can say top select bottom to select the text that's in there, and then we can say ask score like set font size to 30, say. See what happens. And that makes it bigger. Okay, so you know, we can create a turtle and ask one of the turtles to do the things that the turtle knows how to do. We can create a text box and ask the text box to do things that the text box knows how to do. So what I'm doing here is I'm creating a ball that, and I'm going to be able to ask the ball to do things that the ball knows how to do. Okay, so how do I set this up? So I'm going to create a class of balls. Okay, so it's just like here. If you look up here, this isn't the turtle itself. This is the thing that you use to make the turtles, right? And this isn't a text box. This is the tool you use to make the text boxes. So a class in Code Sculptor is basically, that's what you use to make objects of a certain kind. So we're going to define a class ball so that we'll be able to make individual balls to put on the screen. Okay, so how does that work? So what we do is first you say class, and then whatever the class name is, and a colon, and then under that we're going to define all the information and the behaviors that belong to this class. So like if we're in micro worlds, if you look at a turtle already has a whole bunch of state information with it, and it has a whole bunch of different behaviors that it can do, right? It can go forward, left, right, set heading, and all that stuff. Okay, so it's a similar idea here. What we want is we want the ball to have certain values. So I'm going to give my ball a name. We didn't use names over here for the ball, but if I'm going to have more than one ball, I think name might be a good idea, so I can tell them apart. And then start pause, so that's going to be where the ball starts off on the screen. And start, VEL is short for velocity. So the way I'm thinking about velocity, so pause is a tuple, a pair of your x and your y together. Velocity is your change in x and your change in y. So velocity is something like miles per hour, and technically in physics it's miles per hour in a certain direction, right? So so the way we record it is with that dx dy that we used before, the change in x and the change in y each time we refresh the screen. Okay, so that's what velocity is. So I'm storing name, x, y, dy, and dx, and then there's also this self thing. Self is actually a ball object. Okay, so so we could have called it this and made all and so this name, this x, this y, this would work too. Okay, but the convention in Python is to say self, and the reason we have conventions is because when you're writing code, you have to always remember you're writing for two audiences. You're writing for the computer, right? So that when the compiler or the interpreter tries to translate your code into something that the machine can do, that needs to be clear to the computer. But you also want to write things that are clear to other programmers. Okay, so Python programmers have this convention of using the word self here. So we're going to use the word self so that when other people read this code, it's clear to other people what's going on. So self just means this ball itself. So it's kind of like in micro worlds when you the word who, the reporter who, kind of, right? So if you're that's a good example. So if I wanted to say, like if I wanted to get rid of all the turtles on the screen, I could say everyone remove who. Can't I? Let's see. Yeah, and they all remove themselves. So who is just a word of it's a way of saying, who are you? Who am I, basically? So like here it says it's the name of the current turtle. Here it's the ball that is being created right now is self. Okay. So init is a function that's used to create the ball. When we first create the ball, and I'll show you in a little more detail on how that works in a little bit. But basically, what we do is we pass in the name, the start position, and the start velocity, and we're going to create that ball. Okay. Actually, let me flip down to that right now to show you where that happens. So right here we have this assignment statement right here where we say ball equals, and here we're creating the ball. Notice I'm not using the init. I'm not using underscore underscore init underscore underscore to call this function. I'm using the name of the class. So the name of the class is ball, and then I'm passing in. Remember in init, so I kind of skip over this self. This self gets passed in the background, basically. So I only need to pass the name, the start position, and the start velocity. So if I go in here and say, so the name of my ball is going to be bouncy, and I'm going to pass in, this is the position where I want to start. That's the middle of the screen. Remember we did that before. So this is my this whole thing here, this whole tuple is my starting position, my start pos, and then here's this is the X part and this is the Y part. And then the same thing with the starting velocity. I have I'm going, my change in X is going to be 2 and my change in Y is going to be 1. So here's how we pass in all this information to create the ball in the first place. Okay. Then there's this function called underscore underscore str underscore underscore, and that's basically to a way of translating the object into a string. So if you want to get details on the object, so right here I have, and actually the way you could do that is, I'll put that in here so we can see it. Let's print string ball. So in this one, you would just, again, we're not using the underscore underscore. So those underscore underscore functions are kind of special functions that, you know, the way they get used. For the init one, we just use the class name. For that underscore underscore string one, we just use str and the name of the object. And what it'll do is it'll print out this string that gets returned. So notice there's no return value here in for the init business because we're just creating the object. But for a string, you do have to have a return value. And again, you know, and see, so what happens, so you can see that's why we kind of need a little bit of a different function call too, because this ball actually is going to return a ball. So it uses the init function to create a ball, and then it returns one. Okay. Then we have what? Then we have pos, right? So before we had this pos function here to return the x and y. Here we're using pos. Now, with these, actually these functions that are within a class, we refer to them as methods because they belong to the class. They're not really something, you can't call them the way that you can call something out here like dry handler and stuff. You need to use this kind of dot notation that we use. So here you see I'm using ball dot draw. It's kind of like in micro worlds where you have to ask a turtle to do something. So you need to once you create a class of things in Code Sculptor, you have to be able to ask that class to do stuff. So I'm running kind of long, so I'm gonna save the description of the rest of this stuff for the next video.